since you don't raise any questions, I'm going to start with the next lecture, which is about interfaces. Okay, interfaces. In fact, this topic of interfaces is very much based on abstract classes. So if you are not really, you don't really know what abstract classes are and how they work, I'm afraid you might have some difficulties with understanding what interfaces are and what they do. I'm trying to do my best today. So I shared my slideshow with you. This is the slideshow I'm going to present now. And at the same time, I'm going to use Visual Studio to demonstrate some of the usage of interfaces. And furthermore, interfaces are really important in object-oriented programming. They almost as important as classes. And furthermore, in your practice class with Mr. Kushper, you must learn about interfaces, and interfaces will be included in your test with Mr. Kushper. Let me ask you, have you already learned about interfaces with Mr. Kushper? Yeah.
No.
Could you tell? No. What?
No, sir.
No, I think
no.
no.
Okay. Thank you. No, not yet, but you will soon. And I'm telling you, interfaces are really important. Are a really important part in one of your tests during the practice class, exercise class. Okay, let me share my entire screen, and here is my slideshow. Okay, let me start. So interfaces. Let me just jump to this slide here. So at the top, you can see an abstract class. Let's recall, an abstract class is a class which contains at least one abstract method or property in C#. Anyway, this is an abstract class which contains one abstract method. As you can see, this abstract method doesn't have a body here. It doesn't have those brackets at the end. The method header ends with this semicolon, so the body is missing. This is something I was asking about in the Kahoot quiz. So an abstract class doesn't have a body. Anyway, this is an abstract class which is entirely abstract. There is nothing as just this abstract method. So sometimes you can have entirely abstract classes in your code, only with abstract methods and abstract properties. So actually interfaces relate to entirely abstract classes. Actually, they are quite the same. As you can see in this second box, today we learn about a new keyword in C#, interface. This is the new keyword, and an interface can be considered to be an entirely abstract class. Okay, let me jump back to the beginning. Before learning about interfaces and what they look like, let me start with this motivation. Why would we need interfaces? So just imagine that you want to implement something very universal. I know that you have a class where you learn about basic algorithms such as sorting algorithms or search algorithms. Did you learn about bubble sort, for example?
Yes.
Okay, what other sorting algorithms you learned about?
Insert.
Insertion sort.
Shell.
Shell sort. Mm-hmm.
And Sentinel.
Bubble sort.
Sentinel.
Sentinel. I don't know what that is. Okay, good. Okay, fine, thanks. So you learned about sorting algorithms, and sorting algorithms are universal in the sense that they can handle any types. So if you want to sort integers, you use the same algorithms when you want to sort floating point numbers or strings, or let's say you want to sort students based on their grades or something like that. So you can use the same bubble sort algorithm, for example. Okay, the question is, how can you implement such a universal sorting algorithm in your code, in your C# code? What do you need for that? Well, you need only one thing. You need to implement how to decide that two instances of your type can be compared against each other. So if you have two such instances, which one is less than the other one, which one is greater than the other one, and when they are equal to each other. If you implement this, only this, you can use your universal sorting algorithm. For example, bubble sort. So how to implement this in C#? First of all, you must create a new class. Let me call T. And inside T, you have to implement a method. Let me call that compare2, which compares two instances of T. Typically, we compare the current instance of T, called this, with another instance received as a parameter, let me call x. So now we compare this against x, and typically these are the return values: -1 if this is less than x, and so on. You can read. Sorry, here I left some Hungarian words. Let me just correct this. Okay, so this is a very typical solution. Or even better, you make this class abstract. And let me give a more catchy name: sortable. So I create an abstract class, sortable. I put an abstract method inside. It is abstract because at this point I cannot implement it. I cannot tell how to compare two instances because this is just an abstract type now. And then, this is important, then you create child classes of this abstract class. For example, student. So student is the child class of sortable. Therefore, you must override this single method compare2 with a body. You see here, this method has a body, and inside the body, you have to implement how to compare two students based on their grades or based on their Neptune ID or I don't know what. it's up to you what you put here. And you can keep going. You can create other child classes. For example, if you want to compare two cars, for example, just create a class car, make it be inherited from sortable, and override the compare to keyword. And inside the car class, I don't know, you could compare two cars based on their, I don't know what kind of properties. Do you have any idea how to compare two car instances? Based on what? Any good idea?
Highest speed.
Let me see. Yeah, production year. Good choice. Good choice. So you could compare two car instances based on their production year and return -1 or 0 or 1 based on that. Good choice. Or the pass distance. This is even better. How many distance they already passed. Thank you. This is absolutely up to you, what you put in the body of compare to. Thank you. And yeah, so you can try also, if you need to compare strings to each other, you should inherit the string class from sortable. If you want to compare integers, you should inherit int for from sortable, and so on. So this seems a good solution, but here is a catch. You cannot inherit an existing class, for example, a string, from your class. You know, string is an already existing class inside the .NET framework. You cannot make it be inherited from your class. This is not possible. And you cannot inherit integers, floating point types, all the existing types from your classes. You can only inherit your classes from your classes. So this is a limitation here. In 10 minutes, I have to restart the Zoom session. Okay. So this is the problem with this solution. And we have another problem here. As you know, in C# and also in Java, a class can have at most one parent class. This means C# and Java provide only single inheritance. And typically, you want to do several, you want to add several functionalities to your classes. Here, I add the functionality of sortability to my student class. But what if I want to make it also searchable? Because you learned about searching algorithms as well, search algorithms like linear search and binary search. So what if I would like to use search algorithms on my student class? Can I enumerate here several such parent classes? No, in C# you cannot do that. Yeah, so this is a really tough limitation. The problem here is that abstract classes are too restrictive because of single inheritance. We need something less restrictive. We need something which provide less, but at the same time provide multiple inheritance. So this is where interfaces come in. Basically, an interface describes a functionality. functionality of classes. So interface describes a functionality, and you can implement this functionality, apply this functionality to classes such as student, the student class, the car class, whatever class. So actually, interface defines a functionality. It's not a class, and not even an abstract one, because classes are too restrictive, but really similar to classes, as I already explained. This is very important. Interfaces cannot contain any real methods or properties. I mean, interfaces cannot contain any implemented methods or properties. Only the signatures, the headers of methods and properties, which means they all are abstract. They cannot contain fields or constructors either. Yeah. So basically, an interface shows us how methods and properties look like. You see how they look like. What is the name of the method? What is the parameterization? What are the parameters? And what is the return value? There is no implementation. We can only see what they look like. This is why we call this language element interface. You know, what do I look like? This is my interface. Furthermore, an interface is always public. So everything inside the interface must be public because of the same reason. The interface is what anyone can see. This is my public interface, right? There is nothing behind. What is behind is already implementation. Okay, back to this slide. So as you can see, an interface is the same as an entirely abstract class. You have to exchange the abstract class expression with the interface keyword, and also you have to remove the public and abstract keyword in front of the method, because we know that everything in an interface is public and abstract, so there is no need to write those keywords, and that's it. This is an interface. Yeah, I hope you understand. In C# and in the .NET framework, there is a naming convention as well. You are supposed to put the I letter in front of the interface names. This is not mandatory, but somehow required. If you check out all the interfaces in the .NET framework, they have the I letter in front. And this is important somehow because, you know, you can decide what the type is, either a class or an interface, by just looking at the name of that type. Okay, this is a summary. So again, just start to read the slide. I already explained most of those statements, but there is a few more. For instance, this one, the fifth statement. If you have an interface and you create a child class from this interface, you don't have to use the override keyword. This is something new, something special. Yeah, constructors, destructors are prohibited, and the last statement is also new. An interface cannot contain any static elements. This is also prohibited. So only instance level elements. Okay, here is an example. I have 3 minutes left from this session. I think that should be enough. So let me ask a few questions here. You can see, no, let me just explain the first statement here. So as you know, in C#, there is single inheritance between classes, but, and this is very cool, you can inherit any number of interfaces, as you can see in the example. So this circle class is derived from the shape class. So shape is a class, and also from two interfaces. You can see that they are interfaces because they have the letter I in front. So this is possible in C#. Okay, let me ask a question here. Here in the class, you can see 4 methods. 2 methods have the override keyword in front, the other 2 don't. So why do you think this happens? Any idea why those 2 first methods have the override keyword in front and why the other 2 don't?
I guess the other 2 don't have because they are interfaces.
Exactly, exactly. These other 2, the compare to method and save method comes from the interfaces. The draw and clear methods come from the shape class. Exactly. Good. More precisely, the compare to method comes from my iSortable interface, and the save method probably comes from the iSaveable interface. Yeah. Okay, so this is how we can put some kind of multiple inheritance into C#, but this is not real multiple inheritance, not between classes. So it's not the same as in C++ or in Python, where you can use multiple inheritance between classes. In C#, there is something between single inheritance and multiple inheritance, thanks for interfaces. Okay, so I guess this is something new to you. Let's see more complex interface. As I explained previously, an interface must consist of signatures of methods and properties. So here you can see such an interface. Yeah, this is a method signature. These are property signatures. From my previous lecture, you know that abstract properties look like those. And I've put a special property here just for fun, an indexer. We learned about indexers several lectures ago, but anyway, an indexer is also a property, so you can put the signature of an indexer inside an interface. So you can put an arbitrary number of method and property signatures in your interfaces. That's it. If you can do even more, you can inherit interfaces from each other. You can inherit not only a class from interfaces, but interfaces from interfaces. And sometimes it really makes sense. And actually, this is what is done in practice in several projects. I will show you some examples later on. So here is an example. Just imagine you are implementing a drawing application, a graphical application. Inside this application, you need a functionality, a drawable, because you want to draw some shapes on the screen. So let's just create a drawable functionality definition that is an interface which can draw itself, which can clear itself, and yeah, just as an example, I've put a property here as well. You probably need to query the x coordinate or the y coordinate of your shape. Anyway, Then let's suppose users want not only to draw, but also to paint those shapes. Therefore, I created a paintable interface here, which is a kind of extension of the drawable interface with a brush color. Okay, and here at the end, I introduce a third interface, iRenderable. So just in let's say in 3D graphics, if you have a 3D space with full of 3D shapes with colors and etc. At the end, you have to render the image. I mean, you have to put the image on the screen. This is called rendering, and for rendering, you need to paint the shape. So this interface is derived from iPaintable, and for whatever reason, it is also derived from iSortable. You will have a introductory subject on computer graphics, and you will learn that if you want to render a 3D image, you have to start with the objects which are very far from you, and then you render them in an order. The last one will be the one which is the closest to you. So therefore you need to sort the objects, right? And for this, we could use our sortable interface. Okay, do you get it? Get this?
Yes.
Okay. Okay. Great. The last slide of this kind. Whenever you implement, whenever you derived a class from an interface, you should use this terminology. The class does not really derive from the interface. It rather implements the interface. So this is the official terminology. The class implementing the interface, because this is what it does. It implements all the abstract methods and properties coming from the interface. Here you can see a special case. I have an interface and I derive, an abstract class implements that interface. Since it abstracts, since the class is abstract, it's not mandatory to implement all the stuff coming from the interface. It's abstract, so you can select which method or property you would like to implement. You don't have to implement all of them. This could also happen. Okay, so let me tell you. Okay, let me restart. So we learned new stuff last time and also today. We learned that besides our classes, there are certain special classes, abstract classes, which are really important. Last time I explained to you that in big software projects, you have plenty of classes in an object hierarchy. This object hierarchy is a tree data structure. You know, the object class is on the top and you put everything below. And I also explained to you that on the top of this hierarchy, there are typically abstract classes. Below those abstract classes, you have the non-abstract classes, the concrete classes. Today, we learned that besides classes, besides this class hierarchy, we have also interfaces. Interfaces can be considered to be extensions, functionality definitions, which can be implemented on demand by our classes. So just imagine that we have a set of interfaces here next to the class hierarchy. Actually, those interfaces can be inherited from each other in a very chaotic way. So the hierarchy of interfaces is not a tree, it's rather a graph. Anyway, and whenever you want, you can pick one interface and pick one class and make the class implement that interface. So therefore, you can link your interfaces to separate classes on demand. So the overall picture gets much more complicated than it was before, I guess. But actually, this is what happens. What happens in real life. Let me show you an example here. Can you see my Visual Studio?
Yeah.
Okay, so thanks. Let me search for some class you know very well. For example, the list class. If you click on any of the types in your source code, you can check out its definition. Then Visual Studio brings you to the source file of the class. Now here you can see that list is a class which implements lots of interfaces. You see, all are interfaces because you can see the I letter at the beginning. So many interfaces, so many. So this really happens in real life. And I guess all those methods and properties are coming from some of those interfaces. For example, let's see, the add method, which you used so many times, is coming from where? I don't know. Probably from the iList interface. Let's check out the definition. No. Then maybe from here, probably. Here it is. So the add method is introduced by the iCollection interface, which is implemented by the list class. But I could show you other examples here. For example, let's see, StreamReader is a class. You know it? Okay, this is something different. StreamReader is derived from the TextReader class. Let's check out the TextReader class. This is much more interesting. The TextReader class is an abstract class which is inherited from a class, and also it also implements an interface. Okay, so these were some examples you could easily check in Visual Studio. Yeah, so let's see what's the situation in other languages. In Java, same as in C#, nothing special. In Java, there are interfaces, there is an interface keyword. Okay, inside interfaces, it seems you have to write the public keyword, but you can get used to it. And also here you can see a class which implements two interfaces. Here you can see that actually in Java, there is an implements keyword you are supposed to use here instead of the colon. But yeah, this is only syntax, nothing else. So yeah, in Java, you can do the same. You will do the same. Okay, I always check what C++ and Python provide. In C++ and Python, there are no interfaces because here is the main reason. As you already know, they provide multiple inheritance. Therefore, there is no need for interfaces in those languages. In Java and in C#, there is only single inheritance. This is why we need such a language element interface, which can somehow provide something like multiple inheritance. It's not real multiple inheritance, but very close to that. In C++ and Python, we don't need that at all. Do you have any question regarding the material I already explained?
No, sir.
Are you sure?
Yes.
Don't be shy. Or maybe all this what I explained is really trivial. We will see in the next Kahoot quiz how trivial they are. Okay, then let me continue. So now I will show you some important interfaces in the .NET framework, in the base class library inside the .NET framework, because as you saw, there are so many interfaces used in the .NET framework. We checked out the list class. The list class is inside the base class library. It implements lots of interfaces which are also part of the base class library. So the base class library includes lots of classes, lots of interfaces in a similar way I already explained to you inside the class hierarchy and in a set of interfaces. I think you couldn't see what I was showing. Yeah. So so now I pick some of the important interfaces in the .NET framework, and I will explain why they are super exciting and how you could use them in a very, very nice and pretty way. Let's start with iComparable. iComparable contains only one method, compare_to. I hope this is familiar. I already implemented such an interface, you know, this interface here, iSortable, with this kind of method. So this work I did here was completely unnecessary because there is such an interface, there exists such an interface already in the .NET framework. It's called iComparable, so I could use it. There is no need to implement my own similar interface. Furthermore, you don't need to implement your universal sorting algorithm because this is also already implemented in some way. For example, inside the list class, there is a sort method. Let me show you. So now I'm inside the list class, and here is the sort method. Actually, there are 4 versions of the sort method. I'm going to use the one without parameters. It says it sorts the elements of the collection using the default comparer. This is interesting. Yeah, this is interesting. As I explained to you, if you want to sort something, sort a list, for example, you have to be able to compare two elements of the list. So this is here, this sort method uses the default comparison between the elements. Okay. Okay, so let me show you how to use this interface and how to use this sort method. So here is a software project that we implemented with one of my student groups. It's about real estates, such as buildings or farmlands. And anyway, in this program, we want to manage real estates, houses, lands, or whatever. So at the beginning of my program, let me just create a list of real estates. Let me call it real estates. Let me create a new list. Okay, and let me just add a few real estate instances. Each instance have an ID, which is a string, and also a price. So the ID, I don't know, let me just use some dummy ID, and the price in what currency? In euro. So in euro, this real estate costs 80,000. Let me add another real estate with a dummy ID again, a little bit cheaper. And the third one, this should be a little bit more expensive. Okay, and then I would like to sort this list. So here is my list, and as you already know, it has a sort method. Okay, no compilation error. And just to see the results, I write a for each loop and write everything on the console in a nice way. I don't know, let me just put the ID first, then the price. So x.id is the first data, the first piece of data, the price is the second piece of data, then console read key, and let me put a return here because I have something other stuff here which I would like to avoid to be executed. Okay, I guess you understand what I'm trying to do. I'm trying to sort all my real estates and display the sorted list on the console. So let me try to execute it. Sorry. Okay, there are Hungarian error messages, but anyway, here is a stupid restriction we put inside in our program. Okay, let me use Hungarian forints instead of euros, and by doing so I can raise the prices a little bit. Okay. Okay, this is what I was waiting for. Unfortunately, the error messages here are in Hungarian, but I can translate them to you. So here, the framework complains that it couldn't compare two elements of the list. This is the problem. You see, the framework doesn't know how to compare two real estates based on their prices or based on their IDs. They should be sorted in an ascending order, a descending order. This is not. This was not told by me, so this is missing. And here it says you should implement the iComparable interface. The iComparable interface, this one at the bottom, at the top. Okay, so let me show you how to do this. So which class should implement this interface? Since you want to compare real estates, the real estate class should implement this interface. How can we implement the interface? I would like to ask these questions from you to you, but I would like to save some time. So this is how you can implement an interface, right? Here I get an error message. This says you didn't really implement the interface yet. You know, implementing an interface means you have to implement the actual methods and properties coming from the interface. Fortunately, Visual Studio helps you. It gives some hints how to solve this problem, and if you just click on this drop-down list, you can click on the first element, implement interface, just click on it, and the error message disappears by using some magic. Well, actually the magic was that a new method was inserted at the bottom, the compare to method. And that's it. The compare to method has a kind of interesting body. It throws an exception. Therefore, if I execute my program again, you see this is what happens. The sort method calls the compare to method whenever it needs to compare two elements of the list, and now this compare to method throws this not implemented exception, which says, of course, the method is not yet implemented. So you have to remove this line and think about how to compare two real estates based on what. I suggest now to compare them based on their prices. Okay, so basically what we need to do, we need to compare the instance this against the parameter. So I need to compare this against the parameter. Now the parameter is called ob, and if this is the case, I need to return -1, and so on. Okay, but now I suggested to compare the prices. So I want to compare the price of the current instance against the price of the parameter here. But the problem here is that the type of the parameter is object. It's not real estate. Therefore, it doesn't have any price property. So therefore, we need to do something extra here at the beginning. Do you have any suggestion what to do before this if instruction? What we should do here? Anyone? We have an object and we want to turn it to a real estate instance. How to do that?
Cast.
Yeah, casting. This is what you said?
Yes.
Cast. Thanks. Exactly. We can be really sure that the object passed as a parameter is a real estate instance, since inside our list we have only real estates, right? Yeah, that's it. So we have to cast our object to real estate. Now I'm using the as keyword, what we learned about. What's the problem here? Yeah, okay, so. And we can use the result of the cast X. This is how we can solve this problem. Thanks. Okay, I don't have too much time, therefore I would like to continue. I just would like to mention, this is not a nice solution. Here, it would be nicer to use an if with the is keyword, as we learned about, but this is something I leave to you. I'm leaving to you. Okay, if the prices are equal, what should I return? Zero, exactly. And otherwise, I should return 1. So this is the otherwise case. Exactly. I'm not using the else instruction here because the return keyword immediately exits from the function. And that's it. This is all you need. You just implement how to compare two real estate instances. You don't believe me? Now I executed my program and this is what you see. I hope you can see the console. Can you see the console?
Yes.
Yeah.
Okay, so check it out. It's sorted in an ascending order of prices, right? It works. I hope you like it.
Yes.
Okay, great. Then let me ask you a question. How could we sort the same real estates in a descending order? What should I change? Descending order. I should change something here. That's the only point I can modify something. So how to put the real estates in a reverse order? Exactly. Thanks for Rasul. We only need to turn -1 to 1 and 1 to -1. That's all. Here it is. Okay, so this is the compare two methods inside the iComparable interface. And actually this interface iComparable is really widely used. This is why I'm talking about this. You should know how to use it. Okay, did you understand all that stuff?
Yes.
Good. Okay, I have only 20 minutes left and the session will end soon, so we need to reconnect again in 7 minutes. But before that, I would like to start to show you the second interface here. And there are other interfaces I plan to talk about, but I'm running out of time soon. Anyway, let me start to talk about this other interface, iComparer. Just imagine the situation. So in my program now, I'm sorting the real estates in a descending order of their prices now. But it could happen that, I don't know, 100 code lines below, I need to sort them to an ascending order. And let's suppose later in my code, I would like to sort them based on their IDs. So it could happen that inside the same program, you have to sort the same list based on, I mean, differently. This is very, very common. So how we cannot solve this problem by using this solution with the iComparable interface, because now the comparison, how we compare two real estates, is hard-coded in this method. You cannot change it during runtime. This other interface gives you a solution in such a case. You can change the base for your comparison during runtime, let's say. So I mean along the code, and you can switch from one kind of comparison to another one. Okay, for this we need to use the sort method again, but another version of the sort method, which takes a parameter. Okay, let me try this. So here in my program, I would like to use the sort method with the parameter. As you can see, and this is something you already know, the sort method have 4 versions, and I'm talking about the 3rd version now. It has a parameter iComparer, which is an interface. Okay, it is interesting because this interface looks like a list. It uses the those two parentheses, and you can put a type between, which tells the comparer what kind of instances to compare real estates. Okay, just watch. So now, if I want to use this iComparer interface, I have to create new classes, comparer classes. So I'm going to add a new class. Let me call that price comparer. Price comparer. And this is what I'm going to, this is what is going to implement the iComparer interface. Here it is, for which you need to specify what types you want to compare real estates. Okay, this is it. Okay, I hope you could follow. Now we get a compilation error. You already know what to do. Just click on the drop-down list, implement this implement interface menu item, and here it is. The methods or properties what you must implement are inserted with this dummy body. Just erase the dummy body and think about how to compare two real estates X and Y. Okay, so if you remember, we just need to compare the prices of those two real estates. In this case, I return -1. In this case, I return 0. And otherwise, I return 1. So now I'm going to sort real estates in an ascending order. Notice that now I don't need to cast, because now the X and Y are of type real estate and not object, because of this solution here. actually such an interface is called a generic interface, and we are going to learn about generics in 2 weeks. Okay, that's it. I have a comparer which compares real estates based on their prices. So how to use this comparer now? I have to pass such a comparer to this sort method. How? Well, I have to create a new instance of my price comparer. Here it is, and pass it to the sort method. That's it. Okay, to sum up, I created a new class which implements how to compare two real estates based on their prices. I instantiate this class and pass the instance to the sort method. And well, actually you get the same result. Real estates are compared in an ascending order of their prices. Now, what comes next is that I'm going to sort my real estates differently here by using another kind of comparer, which does not exist yet. So after reconnecting, I'm going to implement another type of comparer. Actually, I just realized that in the practice class with the Gábor Kusper, you are not going to learn about this stuff. You are not going, probably you are not going to implement existing interfaces from the .NET framework. You will rather implement your own interfaces with him. So this, what I'm explaining now is a topic you learn about only in my lecture. Okay, let me continue. I hope you all are really excited because of programming, of course, not because of something else. Since I cannot see what you are doing right now. Okay, back to here. So I would like to use another comparer, a comparer which, I don't know, use the descending ordering of based on prices. So if I want to do that, actually I have to create another comparer. Let's call it, I don't know, inverse price comparer. I just made this name up. I have to, again, I make it implement the comparing interface over real estates, and I just need to use almost the same implementation as Rasul suggested before, but to exchange ones and minus ones. This is the real inverse price comparer. Okay, back to my main procedure. Here I'm going to pass an inverse price comparer to the sort method. Okay, let's see. Okay, here it is. You see? Now, for the second turn, the real estates are sorted in a descending order of their prices. Okay, I have still 10 minutes left. Therefore, I would like to implement a third kind of comparer, because I would like to sort real estates based on their IDs. So let me call that ID comparer. Yeah, it's getting boring. I'm implementing the iComparer interface over real estates. Okay, I knew that. I need to implement this interface. Yeah, okay. Erase the dummy body. And now, what I'm trying to do, I'm trying to compare the ID of X with the ID of Y. And the IDs are strings, so these are the IDs. It's a good question. What will happen now since I'm comparing two strings? How to compare two strings based on the alphabetic order or what? Well, first of all, we get an error message here which says the operator less than is cannot be applied to strings. Yeah, so that's a problem. Now ID is not a number, it's a string. So what to do now? It's a good question. Okay, since I have only 9 minutes left, let me show you what we can find out about strings. So ID is a string, right? Let's just look string up. If I go to the definition of a string, I can find out that actually a string is a class. Actually, it's a sealed class, which implements lots of interfaces again. The most important here is iComparable, which means inside the string class, the compare_to method is already implemented here. So it's already implemented how to compare two strings based on what? I don't have to implement this. Okay, what does this mean? It means that this string already have a compare_to method, which takes another string and it returns either a -1 or 0 or 1. In fact, it returns either a negative number or 0 if the two strings are equal, or a positive number. I couldn't really know what kind of negative or positive number it returns. Anyway, this is how you can use the compare_to method to compare two strings. It's easy. Yeah, actually we can simplify this code before I run my program. As you can see, whatever the strings compare_to method returns, I have to return the same. If it returns a negative number, I return a negative number. If it returns 0, I return 0. If it returns a positive number, I must return a positive number. So basically, what I'm doing is very simple. I'm simply returning the return value I get from the strings compare_to method. Yeah, so this implementation I think is really nice because it says that I'm comparing two real estates by comparing their IDs, and whatever is the result of the comparison, I return it. Okay, let me run a test here. So I need another sorting using my ID comparer, and that's it. Okay, here it is. Yeah, now you can see how the string class implements the compare_to method. It means strings are compared based on their alphabetic order. Nice. Okay. Do you have any question? First of all, second, can you tell me how to sort real estates in a descending order based on their IDs? So this gives me ascending order. Now I would like to reverse this order to descending order. What to do here? How should I turn this to a descending order easily? Yeah, this is also good. Rasul suggests to change X and Y. I didn't think about it. Nice. This is nice. Let me show you what I was thinking about. I'm just negating using the minus operator at the beginning. This is the same. So you are perfectly right. Oh, sorry. You are perfectly right. Let me keep your version. Okay, nice. I have a few minutes left. During those few minutes, you can ask your questions, but I'm not going to stop only if you raise your question. I would like to show you something. Meanwhile, let me go back to the price comparer, where it is, price comparer. So this is the comparer which compares two real estates based on their price in an ascending order. They put them in an ascending order. So actually, the price is a uint, you see? So what if we would try to check out the definition of the uint? Let's try this. Go to definition and look at that. The uint is a struct. It's defined as a struct in the .NET framework. Structs can also implement interfaces. I didn't mention that, but you know, structs and classes are quite the same, including the iComparable interface. So it's already implemented inside this struct how to compare two uints. Okay, please explain me how to simplify this code. What should I return in one line? Since now I know that X and Y has a compare, the price has a compare to method. Okay, no solutions. Probably it's too trivial. This is why you don't want to answer. Yeah, that's it. So you can do the same what you did with the IDs actually, because uint is also uint also implements the compare to interface. So this is what you can do in the price comparer, and similarly you can do Rasul's solution on price over prices in the inverse price comparer. Like this, right? So, okay, the result is again the same. So I hope you don't mind if I'm showing you always the same results. The code differs very much. Okay, it's end of the lecture. So just to give me a short summary, we learned about interfaces today, and most importantly, we learned about existing interfaces in the .NET framework, which you could use in a very pretty way in your code. You can reuse all this already implemented stuff, for example, the sort method and those interfaces I was talking about. You can reuse the comparers of strings and uints and all the existing types. For example, the float type, the double type, also implement the compare to iComparable interface. Why should you implement something which is already implemented, right? So this topic is about this stuff. And next time we are going to learn about a few more interfaces which are really pretty to use, but it's a little bit difficult to implement. Interfaces which you already know, for example, the iList interface, it looks familiar, and some other interfaces. So next time. Thank you for your attention. See you next week. Have a nice week. Bye, guys.
Bye.
Thank you.
Bye.
Bye-bye.
Mm.